Hello, my dear students. Welcome to IKSR chemistry classes. Here we are in lecture number 6 on nuclear chemistry. In this video, we will discuss the liquid drop model of the nucleus. Various models have been presented for the explanation of behavior of nucleus of atoms, and liquid drop model is one of them. First of all, let us see the historical perspective of the liquid drop model. The liquid drop model of the nucleus was proposed by Niels Bohr and J. Wheeler in the year 1939. According to this model, the nucleus is treated as a homogeneous entity containing a certain number of nucleons, and each nucleon is assumed to interact strongly with all its neighbors. It means the liquid drop model was proposed by Niels Bohr and J. Wheeler in 1939. According to this model, the nucleus is a homogeneous entity and it contains a certain number of nucleons. It means the composition of the nucleus is uniform throughout, and each nuclear particle interacts strongly with all its neighbors. Similarities between the liquid drop and the nucleus. There are a number of similarities between the liquid drop and the nucleus, and some of them are summarized below. The drop of a liquid and the nucleus both have a large number of particles. The drop of a liquid and the nucleus both have very large number of particles. For example, 0.05 ml water contains about 10 to the power 21 molecules of H2O. Similarly, 0.05 ml nucleus contains even more number of nucleons, 10 to the power 37 nucleons. This number is very high. Both liquid drop and the nucleus are homogeneous and incompressible. It means both liquid drop and the nucleus have the same composition throughout and they are incompressible. That is, their volume cannot be reduced by applying pressure. Density, charge, and other properties are the same throughout a liquid drop and a nucleus, except near the boundaries. Both in the liquid drop and in the nucleus, density, charge, and other properties are uniform, and hence the nucleus and the liquid drop are homogeneous. However, the properties near the boundaries vary from that in the bulk. The surface properties are different from the bulk properties in both liquid drop and the nucleus. It implies that the volume of the nucleus will be directly proportional to its mass, and mass is directly proportional to mass number. It can be seen as follows: D equals to m by V, or volume is equal to m by D. Since density is constant for nucleus or liquid drop, volume will be directly proportional to mass. Volume is directly proportional to mass and mass is directly proportional to mass number. Therefore, the radius of the nucleus will be directly proportional to the cube root of its mass number. On this basis, the radius of the nucleus will be directly proportional to cube root of its mass number. Radius is directly proportional to a to the power 1 by 3. And it can be seen here, volume of a spherical nucleus is equal to 4 by 3 pi r cube. It means r cube will be proportional to volume, and volume is proportional to mass number. It means RQ is proportional to mass number, and therefore R is proportional to 1 by third power of A. That is, R is proportional to cube root of the mass number. It can be written as follows: R is equal to R naught into mass number to the power 1 by 3. Here R naught is a constant, and the best approximation of R naught is 1.4 femtometer. That is 1.4 into 10 to the power minus 15 femtometer. We can calculate the radius of a nucleus using this relationship. If we know the mass number of a nucleus, its radius can be calculated. From this equation, R is equal to R naught into a to the power 1 by 3. Now the time for a self-assessment. Calculate the radius of aluminum 27 nucleus. Here A is equal to 27. The mass number of given isotope of aluminum is 27. Then we have to calculate its radius. R is equal to R naught into a to the power 1 by 3. R naught is equal to 1.4 femtometer. A is equal to 27. And the cube root of 27 is equal to 3. 1.4 into 3 femtometer. It is 4.2 femtometer. It means the radius of the nucleus of aluminum 27 is 4.2 into 10 to the power minus 15 meter. It is very, very small. The third similarity between liquid drop and nucleus is given here. The comparison of a nucleus with an ideal liquid solution implies that the force between all the nucleons is the same. In the ideal liquid solution, the force between solute and the solvent is same anywhere in the ideal solution. Similarly, in the nucleus, the force between all the nucleons is the same. It means the nuclear force acting between neutron and neutron is approximately equal to that acting between neutron and proton, and it is again approximately equal to the nuclear force acting between two protons. The nuclear force is thus independent of charge and spin. Neutron interact with the same strength as proton, and thus nuclear force does not depend upon charge and spin. The fourth similarity, the evaporation of a liquid drop is similar to the emission of radioactive rays from and radioactive isotope. The liquid drop evaporates and its molecules goes to the atmosphere. Similarly, the radioactive isotope emits radioactive rays from the nucleus. It is evaporation of a liquid drop. The liquid drop undergoes evaporation and its molecules go to the environment. Similarly, the radioactive nucleus Radioactive nucleus is unstable and it emits radioactive rays. These two properties, evaporation of a liquid and emission of radioactive rays from the nucleus of radioactive isotope, are similar. The enthalpy of vaporization of a liquid drop is similar to the binding energy of nucleon in the nucleus. In the nucleus, the nuclear particles are bonded together by certain force which is called nuclear binding energy. Similarly, in a liquid, the molecules are held together by intermolecular attractive force. Some energy is required to remove molecules from a liquid drop. Similarly, some energy is required to remove a nuclear particle from the nucleus. For example, the enthalpy of vaporization of water is plus 40.66 kilojoule per mole, and similarly, the binding energy of a nuclear particle in He4 nucleus is 7.045 mega electron volt. The water molecules in the drop of water are held together by certain intermolecular force, and if water molecule is evaporated, this amount of energy is required. Similarly, if we want to remove a nucleon from He4 nucleus, this high amount of energy will be required. Like a liquid drop, the nucleus also displays surface tension, which is directly proportional to the surface area of the nucleus. The liquid drop and the nucleus both display surface tension, and this surface tension is directly proportional to the surface area. It means the surface tension of a nucleus is directly proportional to 2 by 3rd power of the mass number. Radius is proportional to 1 by 3 power of mass number, and the surface tension, which is directly proportional to r square, and therefore the surface tension will be directly proportional to 2 by 3 power of the mass number. Surface tension of a nucleus is directly proportional to 2 by 3 power of the mass number. Like a liquid drop, a nucleus may form a compound nucleus by capturing a high energy particle from the outside. This should be from. Like a liquid drop, the nucleus may capture high energy particle coming from outside, forming a compound nucleus. The excess energy of the particle which is being captured is shared among all the particles of the nucleus or the liquid drop. A liquid drop or a nucleus may capture a high energy particle coming from the outside, forming a compound drop or a compound nucleus, and the energy of the particle coming from outside is shared between all the particles of the nucleus or the liquid drop. Let us see. This is a small moving particle. It is being captured by the nucleus, forming a compound nucleus, and the kinetic energy of this moving small particle is distributed among all the nucleons. This is not localized. Its kinetic energy is not localized in the nucleus. It will be delocalized. It will be shared among all the nuclear particles. The de-excitation of the excited liquid drop or the excited compound nucleus may occur by one of the following processes depending upon the energy of excitation. The excited liquid drop or the excited compound nucleus undergoes de-excitation by various processes, and the process by which de-excitation takes place depends upon the energy of excitation of liquid drop or the nucleus. A liquid drop may undergo de-excitation by cooling. Similarly, a compound nucleus may undergo de-excitation by emission of radioactive rays. A liquid drop may undergo de-excitation by evaporation of some of the particles. Similarly, the nucleus may undergo de-excitation by the emission of one or more nucleons. And finally, the liquid drop may come to the lower energy level by breaking into two smaller droplets. Similarly, the excited nucleus may undergo de-excitation by fission into two smaller nuclei, and this process is called nuclear fission. Like different drops of a liquid have the same density. Different drops of a liquid have the same density. Similarly, the density of all the nuclei is almost constant. All the drops of a liquid have the same density. Similarly, different nuclei which are made up of same neutrons and protons have the same density, and the density of the nucleus is of the order 10 to the power 17 kilogram per meter cube, that is 10 to the power 13 gram per centimeter cube. This density of nucleus is very high. In a liquid drop, the molecules are influenced by only those which lie in the immediate neighborhood. In a liquid drop, only those molecules interact or influence each other which are present in immediate neighborhood. It means the intermolecular forces are short range forces in the liquid drop. Similarly, the same is the case in a nucleus. The nucleus also behaves like the liquid drop. The nucleon force operates. The nucleon forces operate within short ranges only. In liquid drop, only those molecules interact with each other which are present in close vicinity. Similarly, in the nucleus, the nucleon forces operate only within short ranges, and this range is 2 to 3 femtometer. The nucleons can move inside the nucleus, like the molecule can move inside the liquid drop. The molecules can move throughout a liquid drop. Similarly, the nucleons can move inside the nucleus. Two smaller liquid drops may merge together, give a bigger drop. Two small liquid drops may coalesce together, may merge together, giving rise to a bigger drop. Similarly, two lighter nuclei may undergo fusion to give a bigger nucleus, and this process is called nuclear fusion. Two smaller nuclei are approaching each other, and they collide with each other. As a result, they fuse together, forming a bigger nucleus, and this process is called nuclear fusion. Thus, there are a number of similarities between the liquid drop and the nucleus. However, The merits of liquid drop model can be summarized in a few points. It behaves satisfactory explanation for the nucleus in the excited state. It provides, not behaves, it provides the liquid drop model of the nucleus provides satisfactory explanation for the behavior of nucleus in the excited state. The liquid drop model provides a satisfactory explanation for the behavior of nucleus in the excited state. It explains nuclear fusion and nuclear fission satisfactorily. The liquid drop model explains the phenomena nuclear fusion and nuclear fission in a satisfactory manner. And based on these and similar other ideas, it has been possible to develop an equation for calculating the binding energies of different nuclei. On the basis of liquid drop model and similar other ideas, it has been possible to develop an equation for the calculation of nuclear binding energy of different nuclei. The liquid drop model of the nucleus has some demerits, some shortcomings also, as mentioned below. This model does not explain magic numbers. Magic numbers will be discussed in the next video, and these are not explained by the liquid drop model. The charge independent liquid drop model of the nucleus does not explain the fact that protons have a tendency to be paired up in the nucleus among themselves. The protons in the nucleus have a tendency to get paired up. Similarly, the neutrons also have a tendency to get paired up among themselves in the nucleus, and these phenomena, these facts cannot be explained by liquid drop model of the nucleus. Thank you for watching the video with concentration. Please like and share it. If you have not subscribed my channel yet, please subscribe it so that you may get information regarding my new videos in time. Thank you again.